Good morning, fellow nerds. Welcome to another thrilling episode of Between Two Nerds. I'm Jeff Doyle, and you may notice that we are short a nerd this morning. Jeff Tansura is on vacation in Tbilisi, visiting family, I believe. He's been posting lots of pictures of delicious Georgian food. So, Jeff, have a lot of fun, and he'll be back on the 23rd. But in the meantime, I have a special guest, my friend and co-author, Khaled Abuelenain. Sorry, I just stumbled over your last name.
No one knows how to pronounce it. Don't worry.
But what we wanted to talk about this morning is network automation and programmability, and we'll get to that in a second. But Colin, I thought first maybe just introduce yourself a little bit to the audience.
Definitely. So first of all, Jeff, thank you for having me on the show. Like I said, this is my first time on a live stream, and it seems a lot of my firsts are with you, Jeff. So thank you for that. So my name is Khaled Abuelenain. I'm from Egypt, but I live and work in Saudi. Right now, I'm in Cleveland, in the US, and not in Riyadh. I work for a company called Accurative. I'm the consulting director for Accurative for the Middle East region. I basically had the department responsible for delivering projects. So you can basically call me consulting / service delivery / professional services. And I had that department, which is responsible for the professional services part. I have been in the networking business for the last 20 plus years. I'm a double CCIE, routing and switching and service provider. And I'm a DevNet 500, and that is something I'm very proud of. DevNet 500 is basically a group of people, the first 500 people or engineers who got DevNet certified. Okay, sorry, I think the light in my office is motion has a motion sensor.
Oh.
Yeah, turn it off. Anyway, I think it will turn on right now. Anyway, that's about it. I'm a DevNet 500 member, and yeah, that's about it. And of course, I would like to add that I was a contributing author on Jeff's book. He kindly asked me to work with him on the book Routing TCP/IP Volume 2, second edition. I basically did the labs for the chapters and just a very teeny weeny part of the writing. One of the chapters, just a very small part of one of the chapters. And I am a co-author with Jeff on our latest collaboration, which is network programmability and automation fundamentals. It's on the market now.
Absolutely, and yeah, that's as Khalid mentioned, that's how we got to know each other first. Was on a book I worked on, and Khalid, he said we worked together on the book. On the network automation and programmability book.
Yeah.
Other way around, I guess. Programmability and automation fundamentals. It's a massive book. Don't drop it on your foot; it'll hurt. But in reality, Khalid is the lead author on this book, and that was the reason I wanted to have him on the show today. Is to talk about well, obviously programmability and automation, but really focusing on what do you need to know as a network engineer, a network architect, to really develop your skills in that area, and why do you want to develop your skills in that area? And maybe that's a good place to start, Khalid, is you know, what's important about automation these days?
Yeah. So Jeff, I mean, we've all been there when you have to configure a VLAN or something on 500 switches or 1,000 routers, and then you have to SSH to each and every device to push the configuration that you need to push. And it's not just about the fact that you can do it in 5 minutes versus requiring 2-3 days to do that. It's also about the consistency and accuracy of pushing that configuration. How do you make sure that you push the right configuration and you have the right results on all the devices, and there's consistency in what you do? And not just that, this is the classical reason why people resort to automation in general. But there are a lot of other reasons that automation is a de facto standard these days for managing a network. Think about clouds. Imagine you need to go to AWS and spin up a VM that has Red Hat CentOS, Red Hat Linux, and it has an application and just not just one VM. You need to spin up a whole application that constitutes of more than one server, different operating systems, different applications, front ends, back ends. How on earth would you do this without having to automate the process, the whole workflow? And how would you have it human free without resorting to automation to execute this workflow? So automation is becoming a de facto standard, not just for repetitive tasks, not just for consistency and error-free work. It's also becoming a standard for leveraging technologies such as cloud, SDN, and so forth. So automation is becoming something. It's not an accessory anymore. It's something. It's a must-have. It's a must-have for managing any network. Absolutely. And by management, not just monitoring. We're talking about the whole life cycle. It's monitoring, incident and event management, as well as configuration management.
Yeah, and I've just a little blurb that I've used multiple times in different presentations and customer meetings is something I had read. I can't even remember who said it now, but it said you really cannot remove complexity. You can only move it around, and I think that has a lot to do with complexity in the situations you're talking about, where you're having not just simple task-oriented things to automate, but you've got entire complex workflows, with sequencing, and you have step 1, then step 2, and step 3, and you have to have validation of previous steps all along the way, and all that sort of thing. And you can, if you are skilled in these kinds of, maybe what moves from automation into programmability, that might be a good question to talk about. You can start taking that complexity. It's still there, but you're sort of bringing it underneath an automation umbrella that allows you on the surface to more simply operate your network.
So Jeff, like we say in the book, we start the book, we kick it off by explaining what is the difference between automation, orchestration, and a lot of things. But the more important ones that we would like to discuss on this live stream is the difference between automating a single task, and then orchestration, which is basically having a full pipeline or workflow that you need to automate. So it's not just one task, it's several tasks in a specific order to get to a specific target or to get a specific result. Okay, so you have automation and you have orchestration. And then once we are convinced that we need automation and we have to automate, then comes the question of how to automate this, how to accomplish automation, how to do this. So for you to automate management of a platform or device, you definitely need a device to expose an interface that does not have to necessarily be human friendly or targeted towards human interaction. There is an interface such as a CLI, a router CLI. A CLI, you basically type in a command, you press enter, and then you wait for the output. You read the output using your eyes. So this is a human. This is an interface that is tailored towards human interaction. For you to automate, you need to automate. You automate using software. So you need a software, an interface that's fit for software interaction, not human interaction. And this is our window into going to programmability. So once we know that we have to automate, we need to find an interface that is fit for automation, that is fit for purpose, which is an interface that allows seamless software interaction with your platform that you want to automate the management for. Okay, and from that we move from automation to programmability. Now, the whole ecosystem or the whole paradigm of programmability revolves around the concept of APIs. That today, instead of having a CLI-like interface or an interface like SNMP, or syslogs, you have APIs, application program interfaces. And these are software interfaces that we say that a device or a platform exposes an API. And we say on the other side, for you to access that device through that API, you consume that API. Okay. So now, since we're moving from automation to programmability, and we understand the importance of programmability to be able to automate, and we know why we need to automate, we can start discussing programmability from the perspective of APIs. Now, I would like to reference the book, if you don't mind, Jeff.
Absolutely.
Yeah. So in the book, basically, yeah, I mean,
we both are big on shameless plugs for the book. So
yeah, yeah, exactly. So, but again, Jeff, I mean, it's I mean, the book. I mean, a lot of planning went into the book to describe this mindset and this workflow. That it is first automation, the why and the how, and then how does automation translate into the requirement for programmability, and then what is programmability. Now, Jeff, can you just give me a second? Let me just try to put the light on. I think I look scary on the live stream. Yeah, there you go. There you go. Yeah, I just had to
there
move.
we go. Hey, yeah.
I just had to move my legs for it to turn on. Okay. So now that we are focusing on programmability and APIs, programmability, the whole ecosystem can be summarized in something similar to the OSI 7-layer model. Any ecosystem, any paradigm can be described into layers, where each layer has specific functions inside that layer. And this layer is only aware of the layer above it and the layer below it, and there are well-defined interfaces between that layer and the layers, the adjacent layers. Okay, so similar to the OSI 7-layer model, we have the probability stack.
Yeah,
and it's all based on infrastructure at the very bottom, which is in the very simplest form is a device or a platform that exposes an API. And at the top of the stack, there's an application, and the application could be anything starting with a simple Python script all the way to a very complicated network management system. So that application is attempting to consume the API that is exposed by the infrastructure platform at the very bottom. Okay. So for that to happen, we have several layers in the middle. First of all, we have just below the application layer, we have the modeling layer. Okay. And that maps to Yang, and we're going to cover this in a little while. And then under that, we have the encoding layer. Okay. And encoding might be a little confusing to some people, especially people into programming, because we don't mean UTF-8 by encoding. No, we mean the formatting of the data. And this layer basically has the XML, the JSON, the YAML, and the Google protocol buffers in that layer. And then comes the protocols layer. Okay. And I might have skipped one layer. Actually, the protocols layer comes above the encoding layer. Okay. So it's modeling its protocols, and the protocols are the netconf, restconf, and all the other native REST APIs. And then comes the encoding layer, and then comes the transport layer, which is the SH and the HTTP/HTTPS in its simplest form. Of course, these are just example protocols in each layer, but we do have more protocols. Okay, so I'm not sure if we're going to have time to describe each layer in a lot of detail.
Probably not, but we can always do a subsequent show if people are interested.
Oh yeah, exactly. We'll see the feedback on this. But I mean, basically, in its very simplest form, Jeff, the application uses modeling. A data model is an extensive concept. Data model is basically, in its very simplest form, is just a template. A data model, it's imagine having a BGP configuration of a router, but just removing the explicit values for that specific device and just putting a placeholder. So you have router BGP, and then between brackets AS number.
Yeah.
And then you have all the configuration, removing all the values that are specific to that device and just putting placeholders. So a data model in its very simplest form is just a template. But it's not just a template, it's a template that shows hierarchy. It shows all the data types of all the values that need to be placed, and some other things. But it's just a template with placeholders. That's as simple as it gets at the data model.
It's interesting. What that really follows is a schema that I've preached for quite some time. Around just basic network design. Is I've over the years of doing consulting and such, I've seen so many network operators that start with making a choice about their infrastructure. What vendor do I want to use? How am I going to lay this out? Rather than starting at the top, which is what you're describing, even for the programmability model. This is just for an operational model. Start at the top with your applications. What applications do you want to serve? What users do you want to serve? What does good user experience look like, and all of that, and then start designing your network down
to the business layer.
What's that?
Closer to the business layer.
Absolutely. Start with the business case, and you want to build your network to answer the business case.
Exactly.
Not try to shoehorn a pre-designed network into your business case.
Yes.
And I guess maybe I'm saying too much about it there, but it goes down to what you were saying about a network model, or what I tend to call a network abstraction. Where you have an abstraction of some network without any specific vendor or maybe even protocol definitions at that
Correct.
point. That abstraction is serving your business needs.
At some point, Jeff, it becomes
At
irrelevant.
that point, do you move down? Yeah, to okay, now what decisions do I make about technology and protocols and such? To answer that abstraction and make it work right. And then, okay, now what vendors do I look at that will serve that need? And that's just, I probably said, several minutes more than I needed to on that, but it's very much a parallel to exactly what you're saying of that's just the proper way to design a network.
I fully agree, Jeff, that this is the way it has to be. Starts at the business, the top layer, and then you move down. It's not like you create a network and then you try to match your business requirements to that network. This is what the network can do and cannot do. It shouldn't be this way. It should be the business, and then the business tells you what to do at the lower layers.
Okay. Yeah, and the other part that you had mentioned that I definitely wanted to, and I'm sure most people listening to this show certainly understand this part, but you were mentioning interfaces and APIs. Some of the very rudimentary automation, that I got into in the back in the 1990s were things like Perl scripts and expect scripts that basically just logged into the CLI, and doing some basic task like I need to get all of my interface IP addresses, or I need to pull out router IDs for my OSPF network or something like that, so I can get a list for whatever I'm doing. And the point being, when you're working on that API, you're directly interacting with the network operating system. And nowadays, you don't do that directly through an API, through a CLI anymore. In fact, the CLI itself, in most modern network operating systems, is interacting not
with the API,
with the system, but it's talking to the APIs.
Correct.
So basically, when you build your automation, you're kind of going around the CLI and talking directly to the switch, and so that's an important concept there.
Well, Jeff, I'm happy that you mentioned that. Just to point out, in chapter 4, if I recall correctly, which is the Linux scripting, we give a very basic example of automation using Bash, which is a very rudimentary example, but just to show that to demonstrate what you can do with Bash. So we actually use expect with Bash to log into one of the global servers, the global route servers, and pulling the BGP, not the full BGP table, of course, part of it, and then like opening session, retrieving that the BGP table, and then closing the session using bash and expect. So the nice thing that we transition from all the rudimentary methods of automation all the way up to the actual usage of RESTful APIs through RESTful calls, API calls. And by the way, on the chapter on HTTP, that's exactly what we do. We display how you can actually open a TCP port, a socket on TCP port 80 using the socket library, the Python socket library, and then pushing an HTTP request, receiving the response, and then displaying it on the screen just by opening a regular TCP session on port 80. And then we work our way up with more abstraction as we move along until we get to the point of using the requests library, the Python request library, just to do a very abstracted HTTP, which is an API call using HTTP to a RESTful API. So we transition, we actually take the reader through that journey from a very rudimentary automation to the actual automation that he should be using on real production networks in real life. So yeah, I mean, this is actually displayed in the book. I mean, how we go from opening an SSH session or even a TCP session all the way up to fully abstracted RESTful API calls. Okay, and here it goes again. Anyway, I did not notice this. Anyway, so Jeff, just very quickly before we run out of time, I would like just to describe the programmability stack.
Sure.
Yeah, very quickly. I mean, we started at the infrastructure level with the platform exposing an API, and then the application at the top layer, it could trying to consume this API, and then goes through the modeling layer, protocols, encoding, and transport. So for the application to access that API, it needs to do that using a model. It needs to understand the configuration is going to pull or the configuration is going to push to the platform, what data model it's using, what format I need to use. So that is defined by the data model. And then below that, there is a protocol. So what does protocol mean? I mean, everything is a protocol these days. So what is a protocol in that context? Protocol like netconf or restconf or a native REST API is basically just a set of messages. Now I need to push configuration. What kind of message do I use? I need to retrieve configuration. What kind of message do I use? I need to retrieve operational data. What is the message format? So that's the protocols layer. And then the protocols, they use specific encoding. So let's say, for example, I go for netconf as a protocol, which defines 3 types of messages, which is the hello, the RPC, and the RPC reply. How are these messages formatted? In which language? Is it XML or is it JSON? Is it YAML? Is it Google protocol buffers? So we have the modeling, and then we have the protocols layer. The protocols use specific encodings, and then these protocols are carried over specific transport layer, and not transport layer from the OSI layer as an OSI 7 layer model. No, we call it a transport layer, but it's actually not a transport protocol in the classical sense, which is SSH and HTTP. So that's basically it. I'm sure it's not as clear as if you look at the stack on paper and read the description of each layer, but this should be your guideline if you want to have an entry point into programmability. The programmability stack will explain to you each component and how each component interacts with other components and what does it do exactly. Because I get a lot of questions. Why do I need XML or JSON? What does HTTP have to do with programmability? I'm a network engineer. Why do I have to understand what TLS does? If you understand that HTTP is a transport protocol that is used by RESTconf, and RESTconf uses JSON inside its messages, and this message, the structure, the hierarchy of this message follows a Yang model. You start connecting the dots, understanding the bits and pieces and all the moving parts in programmability. So I mean, that go for the stack, understand the stack, break it down, and then start digging into each of those components. And that's basically what we did in the book. We describe the stack, how each component interacts with other components, and how each layer interacts with each other layer. And then we break it down. There's a chapter on JSON, there's a chapter on XML, there are 2 chapters on HTTP and HTTPS, there's a chapter on SSH, several other chapters, of course, not discussing the chapter on Ansible and the first chapter and the last chapters, which is an introduction, and then moving forward. It breaks down each of those components and discusses this component individually.
And we actually, that is a great comment, because we have a question from one of the viewers. In fact, there it is, from Navissa. How many tools and apps for network automation do we have, and can we address a standard roadmap for it? And kind of what Khaled has been referencing here. You can, sorry, this is maybe more of a shameless plug for the book than I intended, but on page 14 of the book is this automation stack. That's exactly what Khaled has been talking about all along. But as far as Navissa, I think what you're asking, when you say, can we address a standard roadmap for it? That sort of sounds like, how do I develop expertise in this area? And Navissa, correct me if I'm wrong, but just looking at the message board over the side here, but is there a roadmap for educating ourselves and developing our own expertise? Where should we start?
Okay, so Jeff, I mean, that's a good question. Let me just point out something. The OSI 7 layer model is an industry standard for breaking down the functions of any network. The programmability stack, I'm sorry if I can't pronounce this, programmability stack. It's not standardized by anybody yet. However, it's an excellent reference for the components of that ecosystem.
Mm-hmm.
And why am I saying this? Because the word roadmap sometimes, let's say, it doesn't scare me, but it doesn't accurately describe what should be for that ecosystem. Now, roadmap is something that we would describe the plans that a vendor has for a product, but that wouldn't be a good description for what is happening down the line in the industry with respect to automation or to similar ecosystems. The reason for that is automation is a massive domain. It's like I said, it's an ecosystem. There is no one solution that fits all. There's literally hundreds of tools and there are redundant tools that do the same task. So it's basically up to you to understand the fundamentals, and then to understand the use case that you have at hand, understand the tools, and make sure that you're using the right tools for the job. And let me give you an example. Sorry.
No, go ahead.
So, for example, Jeff, in our book, we have a full chapter on Ansible, but everything that you can do with Ansible, you can do using Python and a RESTful API call. With caveats, of course. I don't like to say that everything in entirety. It's not a very accurate statement, technically speaking. But most of what you can do with Ansible, you can do with RESTful APIs and using a simple Python script. And most of what you can do with Python, RESTful APIs, you can do with Ansible. So which tool is best to use? It depends on your use case. You cannot just have one tool for everything. So the word roadmap is not something that I can use to describe something like the programmability ecosystem. There is no roadmap. Every day we have new tools coming up. Protocols are maturing as we move along. New protocols are coming. Let's for example, we had netconf to start with, and then we had restconf, which some people like to call the restful version of netconf. Now we have gRPC and GNMI. You never know where we're heading with this. HTTP2 and HTTP version 3 were developed by Google and then standardized by the IETF. So vendors come up with ideas, people come up with ideas, they implement it, it works, it becomes standardized. There's no one single body that standardizes stuff for the programmability ecosystem. The only facts that we have today are the protocols that we have today, which is RESTconf, NetConf, gRPC, RESTful APIs, but there's no single roadmap for this whole ecosystem. Not sure if I answered the question.
I think you did, and I mean, it's. I know that in chapter 1 of the book, I talked a lot about programmability and automation toolbox.
Toolbox, yes.
And putting your the more complete your toolbox is, the easier it is to do the job. You can have a basic set of household tools and do most things, but you might struggle with a few things. Whereas if you start adding specialized tools in, then all of a sudden you can, fix your plumbing or or whatever. And the same thing, applies here. You mentioned, a good example is Ansible, saying, you can do in Python anything you can do in Ansible. But Ansible is a tool that can also enhance your Python automation. You can make calls to Ansible from Python and that sort of thing. So, you might be writing your overall workflow. Yeah. And within that saying, okay, I want to use Ansible for this piece of it, because Ansible already does those things, that I want to do at that stage. And, so why reinvent the wheel?
So Nafisa seems to, if I'm sorry if I'm not pronouncing the name correctly. In Arabic we call Nafisa. I'm not sure if this is the right pronunciation. I think she agrees with me that Ansible is a great tool, but as I go further, it gets harder to automate. I'm thinking of migrating to Python-based tools like Normir, and I have a lot of friends who are under the same impression that Ansible is a good starting point for automation. But eventually you have to they prefer to move to Python based or maybe Go based libraries that are more versatile and more scalable than the Ansible. But just like you said, Jeff, I mean, it's not cut and dry. It's like you can have one tool invoke another tool, and it's just they can work together, one under the other, one calls the other. It's very flexible. Once you get into the ecosystem, it's very flexible. It's not just a single tool for everything.
Absolutely. I mean, and one example, just looking at, for example, in the stack here, at the encoding layer, you could, you might have YAML, you might have JSON, you might have XML.
Yes.
Do you always have to learn all three of those? It's what dictates which one of those is most prioritized for learning?
Well, Jeff, to be honest, let me tell you something, and my friends call me crazy. I like XML.
Well, then I will too.
and they tell me no one in his right mind would like XML over JSON. But let me say, it's not everything that is complex is more capable, but in that case it is. So let me just shed some light on the differences between XML, JSON, YAML, and Google Protocol Buffers. So XML, that's a markup language. That's similar to HTML, similar, not the same. And it was developed way before, network automation was a thing. XML basically, HTML has data, and then it has markup. So what is markup? Markup is basically information that you embed in your documents that describe the data, the actual content. It's not part of the content, but it describes the content. So HTML, it has markup that tells you how this data needs to be displayed on a web page. What is the font? What is the color? What is the location of this data on the web page? XML is a little different than HTML. It also has markup, but the markup, which is like the extra information embedded in the document, tells you what this information means. Okay, so basically you have, let's say, for example, you have an email. The email has a to, at the minimum, it would have a to field. It would have a subject field, and then the actual content of the email. So you have markup, which is information telling you that this line, this is the to field, this line is the subject field, and this paragraph is the content, is the body of the email itself. Okay, in XML we achieve this using elements and tags. Okay, and there are a lot of rules governing what is a well-formed XML document. YAML, on the other hand, actually YAML stands for YAML. It's like a recursive acronym. It stands for YAML ain't a markup language. Okay, so it's actually, to be honest, it used to be YAML, yet another markup language, and then the creators with version 1.2 they changed the naming. The acronym became YAML ain't a markup language. Okay, it's a recursive acronym. Okay, so basically, the people who wrote YAML or authored YAML, they are just telling us that this is not a markup language. It is. It is. It is. They call it a data serialization language, which is basically a way to express data, but it doesn't use markup like HTML and XML. Okay, so it uses key value pairs, and then it has a lot of other syntax and semantics to describe data. And I did not mention JSON because as of version 1.2, YAML version 1.2, JSON is officially a subset of YAML. So most of what we say about YAML applies to JSON. In its very simplest form, it's just key value pairs.
Mm-hmm.
And YAML has a way of describing arrays and lists and other data structures, but it's not markup per se. So that's a the very basic difference between XML and JSON YAML. Now, XML is not very human readable. If you read, and this is why people call me crazy that I like XML. I like working with XML. XML is not human readable, and it was developed to be machine readable more than, I mean, the focus was on it being machine readable and easier and faster to parse. Now, YAML on the other side, one of the main design goals was that it is human friendly. It can be easily understood by humans. That is officially one of the design goals. Actually, they have two design goals. One is that it should be human readable and friendly. The other design goal was that it should be wide enough to be able to serialize or to represent all kinds of data structures. That's the other design goal of YAML. JSON is in the middle. I won't say in the middle. It's a subset of YAML, not as human readable or friendly as YAML, but it is the same thing. It's a key value pair. That's JSON. Now that's XML, YAML, JSON briefly or at a high level. Now, if we decide to use a protocol that only supports XML or only supports JSON, then we're stuck with that encoding format. Netconf, for example, only supports XML. RESTconf supports XML or JSON. Most RESTful APIs support both.
Okay, so as you move up the stack, what you're wanting to do and what tools you're wanting to use kind of dictate
Yes,
to some degree what you need to learn, what you need to focus on.
Jeff, back to what you said at the beginning of this call. Business requirements dictate what you need to do, and then you choose the protocol that will serve your business requirements. And based on that protocol, we then have to see what that protocol supports or does not support.
Okay, cool. And one other question, looks like we've got maybe 7 or 8 minutes left here. I would be remiss, I guess, a little bit, working for Apstra, now Juniper Apstra, if I didn't mention some of the differences between do-it-yourself automation and shrink-wrapped packages.
Okay.
And there are certainly a lot of automation packages out there, not just Apstra, and Apstra is obviously something that we automate, but it's a specialized tool. It's built for automating your data center, and even within the data center, automating within certain parameters. But looking at automation tools that you can buy, that help automate your network, that I think that there is, when you're considering, do I want to learn all of these tools, which I think you and I are in total agreement with, that even if you're doing using shrink wrapped automation tools, you still want to learn these tools in the background. You want to learn Python and
Definitely.
and how to interact with Linux and and all of the lower protocols, because tools, and that's why I specifically pointed out Abstra, tend to have limits of what they do, and you still want to be able to interact with that tool. Looking at just my example, because it's something that I deal with all the time, with Abstra, is okay. We automate your data center, but how does Abstra interact with my ServiceNow ticketing system? How does it interact with IPAM, so that I can, whatever addresses and such that Abstra is using, IPAM can record those things? How does it interact with larger scale infrastructure managers like vSphere and NSXT and maybe OpenStack and things like that? And that's where you still need these kinds of skills yourself to be able to interface.
Definitely.
That.
Jeff,
Yeah, go ahead.
I'm very strongly opinionated about this, and this
Mhm.
is one of the reasons. I decided to write a book about the fundamentals, not about the tools per se. Although we do have a lot of tools covered, but fundamentals are very important. A few days ago, I was designing a network, an SD-WAN, a Cisco Viptela SD-WAN network,
Mhm.
and I noticed something that I didn't hit me before, that the vSmart speaks with the vEdges. The vSmart is the SD-WAN controller, and the
Yep.
vEdges are the edge devices installed in the branches or the data center. It speaks via they speak together via netconf. Okay,
Yeah.
so even if you have a ready-made network management system, off-the-shelf network management system, you will find that all the protocols that are happening in the background, that are being used in the background, are the protocols that we need to learn as fundamentals: netconf, restconf,
Yeah.
RESTful APIs. You need to understand RESTful APIs really well. Of course, not just understanding how these ready-made network management systems work, but also in case you need to customize, in case you need to integrate with other systems. Understanding RESTful APIs, for example, understanding HTTP, a very fundamental understanding of the difference between post and put methods on HTTP, understanding how TLS works, and because HTTP on TLS is HTTPS, which is secure HTTPS, understanding the negotiation process that happens on TLS, which we, by the way, have like 10 pages on in the book.
Mhm.
It's important for you to be able to not just use and operate and understand. It's also important for you to customize an existing tool. It's important for you to be able to integrate with other tools. It's important for you to troubleshoot any issues that you might run into during your work or your operation. So understanding the fundamental protocols and the bits and pieces that are happening in the background is extremely important. I cannot stress that enough.
That is great, and that's actually maybe a good place. We're about 2 minutes
Jeff, if I
left.
may, I just want
Yeah,
to shout
sure.
out to, I just shout out to Ayem Said. I'm not sure if I'm pronouncing the name right. He's just because I did not see this chat earlier. Hi Jeff and Khaled, how are you guys doing? We're doing great, thank you very much. I'm doing great. And to my very dear friend Ahmed Mushrif, just a shout out to Ahmed.
Yeah, Aim and Navisa are both regular viewers,
And of
so
course, Nafisa,
I
first time
see
I
them
got
on most of our shows.
great questions, Nafisa, and
Yeah,
thank you
yeah.
for the question and the discussion that was triggered by that question. Thank you very much.
Yeah, absolutely. And I think this show went exactly where I wanted it to go. We've done a really nice overview
Yes.
of automation tools, pieces that go into the automation stack and the
Yes.
such. And I would love to have you back for some future shows. Now that we've sort of set that, we can start diving down a little bit into
Yes.
these details, and maybe have some more focus shows on each one of these. And
Jeff, it's
So
always a pleasure working with you in anything. That was a real pleasure. And I mean, in case people don't know, you're my mentor, and you got me into writing, and
well,
well, you're getting me into live streaming. So thank you very much, Jeff.
absolutely. And Khaled, thank you so much for
My
being on
pleasure.
the show. And for all of you that are watching, by all means, follow us on YouTube, subscribe to our channel, like us on Facebook and so forth, and keep in touch. And Jeff Tansura will be back in 2 weeks for another show on the 23rd. And in the meantime, enjoy your week, Khalid. Thank you so much,
Thank you, Jeff. Thank you all.
and we'll see you in 2 weeks.